Hello friends, this video on Biomolecules part 4 is brought to you by examfear.com. No more fear from exam. Carbohydrates can also be classified as reducing sugars and non-reducing sugars. So we talk about reducing sugars, all the carbohydrates which reduce failing solution or tolerance reagent are reducing sugars. And the one that doesn't reduce this failing solution, tolerant solution are non-reducing sugars. Please note this reducing carbohydrate should have aldehydes, ketone or hemiacetal link. If it has either of these, they will be a reducing sugar. For example, if you see, this is aldehyde. This is what ROR dash, this is a ketone. This is RCOH, aldehyde, this is ketone. This is hemiacetal where you have OH, this is my carbon here, OH, OR, R and H, this is hemiacetal. So all these three in the black will be a reducing sugar. This is what? This is acetal. That is two different R's and two different OR's. So this you will not be able to reduce. This will not reduce actually the failing solution or tolerance region. So this will be non-reducing sugar. Correct? And please note that we will see that all monosaccharides are reducing sugar. In fact, all disaccharides are also reducing sugar with one exception, and that is sucrose. So all disaccharides, we'll see this also. Such rights except sucrose, they are reducing sugar. So we'll discuss these things in details when we talk about the monosaccharides in detail and disaccharides in detail. Just understand that we have two different types of carbohydrates. One is called reducing sugar, the other is called non-reducing sugars. The reducing sugars are the one which has free aldehydes, ketones or hemiacetal link. Please remember this, aldehyde, ketones or hemiacetal link. If it has, let me add this word free, it has to be free, then it will be a reducing sugars. If it doesn't have, it will be non-reducing sugars. We'll show you these things in details in the next few slides. Based on the number of carbon atoms and the functional group present in the carbohydrates or the monosaccharides can further be classified. Please note, this classification is not for carbohydrates, this is only for monosaccharides. One small unit. So one small unit, as I told, it can have 3 carbon, the minimum is the glyceraldehyde, right? It can have 4 carbon, 5 carbon, that is something like this, right? And you put OH and OH here. This is 1 unit. One unit can have 3 carbons or 4 carbons and 5 carbons. So based on that and also based on the functional group, and we told that the monosaccharides or any carbohydrates will only have aldehydes and ketones, right? So based on this aldehyde or ketone, we call it aldose and ketose, I believe. Yeah, ketose if it is having keto group, aldose if it has aldehyde group. So if the monosaccharide contains aldehyde group, it is called aldose. If it contains keto group, it is called ketose. Correct? And then based on the number of carbon atom, for example, if it has 3 carbon, again we are starting with 3, minimum 3. We explained why. Think, yes, you are right. It is because 3 carbons are required minimum for glyceraldehyde because it is polyhydroxy, right? It is polyhydroxy, so 2 carbon for 2 OH and 1 aldehyde or ketone, so 1 carbon for aldehyde or ketone. So minimum 3 carbon is required. So it starts with 3. So 3 carbon, it is called triose, general term. If it has aldehyde group, so this triose can be further classified as aldotriose or ketotriose based on whether I am talking about aldehyde triose or ketotriose. Similarly, this tetrose is a monosaccharide which has 4 carbon, and this tetrose can further be classified as aldotetrose or ketotetrose based on the fact whether it is aldehyde group or ketone group. So if you see here, my glucose has how many carbon? 6 carbon, correct? And it is aldehyde or ketone? Aldehyde, we have just seen. So glucose will be aldohexose. Why? Because the glucose has 6 carbon and it's part of aldehyde group. We have seen this structure of glucose. Actually, we will see the structure again. It is something like this. 1, 2. Okay, leave it. We'll see the structure in the next few slides. Okay, let me draw 1, 2, 3, 4, 5, 6 carbon here. Right, this is my aldehyde group here, and these all has OH group, right, and this is CH2OH. This is the kind of structure. We will talk about the orientation of this in the next few slides. Just understand this is the kind of structure we have. I think this is OH, and again this is OH, and this is H, and this is OH here, H here, H here, and H here. This will be the structure of glucose, and we will discuss this in detail in the next few slides. So this has 6 carbon, so it will be part of hexose, and since it's aldehyde group, it is aldohexose. Correct? Thank you. Visit examfear.com to watch more videos, attempt free online tests, get free study materials, find tutors and mentors, and much more. Thanks once again.